Okay, now we're going to take a look at number 93. 93 is the next one. These are all kind of questions along the same lines, having to do with distance and perimeters of things and ratios of distances, et cetera, and so forth. So number 93 says the endpoints of one side of a regular pentagon are -1, 4, and 2, 3. What is the perimeter of the pentagon? This one is actually a little bit easier than maybe some of the previous ones, because, and that's only because, that's not the right shape. A pentagon, let's say, looks like this. And a regular pentagon means all the sides are the same length. When they use the word regular, it just means that all of the sides are equal in length. So it gave us the endpoints of one side. So all we have to do is find the distance from -1, 4 to 2, 3, and then multiply that number by 5. So we can do this just with Pythagorean theorem again. -1 over to 2 is going to be 3. From -1 to 0 is 1, and then 2 more. So that's 3 squared. Then we do the y numbers from 4 to 3. That distance is, it's down 1, it's -1, but remember, distance doesn't have positive or negative. It's just 1. So the distance on the x-axis is 3, the distance on the y-axis is 1. So we're going to use Pythagorean theorem to find the diagonal distance, which means C, after I type in my calculator, I'll do those things squared, then take the square root. 9 plus 10, 9 plus 1 is 10, and so it's the square root of 10, right? And then it wants to know if that is one side of the pentagon, then what is the perimeter of the pentagon? Well, if one side is root 10, they're all root 10, because that's what it means for a shape to be regular. So then that would be 5 root 10, because there are 5 of them. Number 93, B, 5 root 10. Yeah, good stuff. In fact, let's just do number 94 in the same video. That was short enough. Same thing, find the perimeter of the triangle to the nearest whole unit. So this is just distance, 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 then add it up. So we have this first point here is at, let's see, -2, -2. This point is at, looks like 2, +2. And this point, it looks like it's at -1, 1, 2, 3. So we're just going to find the distance between these points. Oops. For this one, again, I really just prefer to use the Pythagorean theorem. If you really want to do the distance formula, just get your notebooks out, look up that distance formula. It's the square root of, y2 minus y1 squared plus x2 minus x1 squared equals d squared. It's just the Pythagorean theorem anyways. So I don't see any reason to do that. But we'll find the distance of this triangle, and then we'll do it again here and here. And then we'll do it one last time here and here. And we'll add all those distances together. So again, it's just a matter of doing right triangles and doing Pythagorean theorem. So let's talk about this distance first, from -2, -2 to -1, 3. So from -2, let's do the x. From -2 over to -1, from this number to this number, that's a distance of 1. So we have 1 squared. And then from the y value, from -2 to 3 is a distance of 5. So that's 5 squared. And that equals 1 plus 25, so square root 26. SQRT 26. So that's this first side length. Then we'll do it again, but with this triangle right here. So from -2 over to +2 is 4. From -2, 1, 2, 3, 4. So we have 4 squared plus, and then from -2 up to +2 again is just 4. 1, 2, 3, 4. That's going to equal 16 plus 16, which is the square root of 32. You could simplify these, but because you're adding them all together at the end anyways, it doesn't really matter. And then finally, we'll do the last side, which is going to be this side right here. So this is 1 vertical distance and 1, 2, 3 horizontal distances. So that's 1 squared plus 3 squared. And that's going to equal 1 plus 9, so square root of 10. And so all I have to do now in order to find the perimeter is to add those 3 numbers together. I'll do that on my calculator. Square root of 26 plus the square root of 32 plus the square root of 10 is 14. It's 13.918, but it's to the nearest whole unit. So it's 14. Just make sure you know, again, to find this horizontal distance, or I'm sorry, this diagonal distance, like in order to find a diagonal distance, we just make a right triangle and Pythagorean theorem. And we did that 3 times to find all 3 of these different lengths. I got a couple more I'll do on the next video. So